So I'll share my screen. If anyone can confirm that the screen is visible.
Yes, ma'am, your screen is visible.
Okay. So I'll just start with my session now. So good evening, everyone. Welcome to the fourth live session of the NPTEL course Basic Environmental Engineering and Pollution Abatement. The course has been instructed by Professor Prasenjit Mondal from Department of Chemical Engineering, IIT Roorkee, and I am Chaitra Borkar, a Ph.D. student from IIT Delhi, and I will be conducting this session. So reiterating that these sessions will be conducted on every Saturday from 3 to 5 p.m. and the link for these sessions have been shared with you all. And these sessions are recorded, and these recordings will be made available to you through my YouTube channel. And let's start with the overview of the lectures 16 to 20, which are conducted in the fourth week. So for lecture 16, we saw that the sampling and characterization of air were studied, and the ambient air can be sampled through grab and integrated sampling. So grab sampling is basically taking a small amount of air in a very small amount of time, and integrated sampling is taking a number of grab samples and then taking an average of it. You can also collect the samples using absorption in liquid, and this absorption can be physical in nature or chemical in nature, in the sense that a reaction can occur. Physical is low in efficiency because it's weak absorption, while chemical is stronger in efficiency because it is irreversible in nature. Another way to collect the sample is adsorption in solids. So when the sample has different gases in it, they can adsorb on the solid, and but that does not change the physical or chemical nature of these gases, but they can get absorbed. So but this adsorption has a bit of limitation. Why? Because when these gases get adsorbed, there can be a difference in the desorption efficiency. So different gases can dissolve at different temperatures. So because of that, the adsorption in solids is less used. Next is freeze out sampling. Freeze out sampling is basically progressively decreasing the temperature to very like sub-zero temperatures, and collecting the liquefied version of the different gases present in the air. Next is particulate sampling. So if there are particles in the air, how do you sample it? Like, how do you collect it? So first is the sedimentation. This is basically for particles more than 10 micrometers. This is generally less accurate. The next one is high volume filtration. As the name suggests, it is used for high volume of samples, and it is used to measure particles from zero point 0.1 to 20 micrometers and has a very good efficiency. Then there's a tape sampler. So tape sampler is you have a stream of air, and there's this tape on which this stream of air is projected on, and the particulates get collected on this tape. Next is the impingement, which can be wet impingement or dry impingement. So impingement is basically you are impacting these particles onto a flat surface, and because of that, the kinetic energy of these particles is reduced, and then they get collected. Next is the electrostatic precipitation. This is not widely used, but it's basically using the electric energy to attract so basically charge the particles present in the air, and because of the charge, then they get electric charge, they get collected onto the electrodes. Next is the thermal precipitation. This is like electrostatic precipitation, but it uses temperature instead of the electric charge. So based on the difference in temperature, the particles are collected on a colder they are taken from a hot plate to a colder plate. So they move towards the cold plate because of the gradient in temperature created, and it has a very good efficiency. Next is stack sampling. So the flue gases coming out of the stack from the industries. How do you sample the air from that? So, as you know, the stack can be of different shapes. So, based on that, you need to have a nozzle present in the stack, which collects the air sample. So, the nozzle should be placed in such a way that the air get nozzle should be placed in such a way based on the shape of the stack, and also it should be based on the principle of isokinetic sampling, in the sense that the velocity of the stack air should be equal to the velocity of the air entering into the nozzle. Next is the characterization of the sample. So now we have collected the sample. How to characterize the gas components? So one of the example given was chemiluminescence. It basically is used. The example given there was for the quantification. So the reaction between the ozone and NO, or ozone and nitric oxide, is quantified through chemiluminescence. Then non-dispersive infrared. So infrared is used to characterize the different gas components present in the sample, and the flame ionization detector. So it uses the reduction by hydrogen flame. So if there is an component in the gas which can be reduced by hydrogen, so you can use this flame ionization detector to detect that. For example, if there is carbon content there, it can be reduced by hydrogen flame to form either uh, methane or ethane in that sense. Next is in lecture 17, sampling and characterization for wastewater, water, and effluents was discussed. So first we discuss the grab and composite sampling. This is the same as grab and integrated sampling, but grab sampling is for low volumes, and composite sampling is for bigger volume and at frequent intervals. Parameters for analysis were discussed, and they are in this given order: that dissolved oxygen can be detected by, I mean, the dissolved oxygen can be measured by using the Winkler's method. It's quite an old method in which the reagents used are magnesium salt, iodide, iodide ions, and OH ions. And when we use these reagents into the sample, then the reaction occurs that Mn2 plus salts get converted to Mn4 plus ions, and then we add acid and convert these Mn4 plus to Mn2 plus, and because of that, iodine is evolved. So when this iodine is evolved, we then use titration to detect the amount of iodine evolved, and the amount of iodine evolved is equivalent to the dissolved oxygen. Next is the O2 sensor method. It's basically an electrolytic cell, and it has electrodes, cathode and anode. And a cathode is of gold, and anode is of silver. And because of and there is a semi-permeable membrane below this electrolytic cell, and the sample is there. And the O2 is allowed to permeate through this membrane into the cell, and then this O2 reacts in the electrolytic participates in the electrolytic reaction, and because of that, the current is generated, and the current flow is proportional to the dissolved oxygen. Next is the biochemical oxygen demand. So BOD 5, BOD 5 is basically when you measure the BOD after incubation of 5 days. So for that, we take a blank sample in which dilution water, and dilution water is basically these components written here. So CaCl2, SO4, FeCl3, phosphate, phosphorus buffer, and even you can add microorganisms to it. So this is the blank sample which has only dilution water, and then there is the real sample. So our sample which we need to measure. So uh, the this sample and blank measurement are taken first at t is equal to 0, like for when you are just putting it for incubation, and then after 5 days of incubation. And this incubation needs to be done at 20 degrees Celsius in complete darkness. And then you measure the difference between the two, and then you get the BOD. So, chemical oxygen demand is measured through the reaction between the potassium diachromate with the organic matter which is present in these samples. So, earlier someone had asked that COD is used to characterize the whether the organic content or the inorganic content as well. But basically, potassium dichromate can oxidize inorganic matter as well. But according to this definition, it is only used to characterize measure the organic matter. So, if there are any inorganic matters present in the sample, then you need to first remove them and then use COD method. So, you add the potassium dichromate along with sulfuric acid and heat it, and then if there is any excess dichromate present in the solution, so all the dichromate so the dichromate used to oxidize the sample is basically the amount of organic matter present. So if there is any excess dichromate, it is then titrated with ferrous ammonium sulfate. So this excess dichromate between the blank sample and the original sample, the difference between this can give us the COD uh, COD value. The other parameters for analysis are total organic carbon. So the organic carbon present in the uh, air sample. So the air free of CO2 and hydrocarbon carrier is mixed with the sample, and combustion at low pressure, low temperatures and high temperatures give the inorganic and organic carbon present, and the NDIR method or the FID method can be used to measure the amount present. Next is the bacteriological measurements. So membrane filtration technique is used here, and the coliform bacteria is captured in the filters and then allowed to grow through incubation. The MPN technique is basically a statistical method to estimate the probability of these bacteria colonies of coliform bacteria. The parameters for analysis can be total solids as well. So total solids is the sum of total suspended solids and total dry solids. So total solids are first allowed to dry at 105 degrees Celsius till it attains a constant weight, and then this dried sample is ignited at 550 degrees Celsius to a constant weight in a Muffle furnace. So we get the volatile solids and the total solids in that sense. Um, Also, atomic absorption spectroscopy was discussed, and it's based on the Beer-Lambert's law. Is it's the principle is that the atoms emit certain radiation, absorb certain radiation, and these certain unique radiations. So, based on that, this technique is developed. The lecture 18 was about the characterization and sampling of solid waste and soil. So here also direct and indirect sampling, which is direct sampling is taking through the direct source where the solid waste is generated, and indirect sampling will be taking through these source, not through the direct source, but where the sample, where these solid waste is collected. So next is sample collection, which can be in random, stratified, or systematic or quartering method. This has been discussed. And the physical and chemical properties of municipal solid waste. So the physical properties can be specific weight or density. Uh, the bulk density or apparent density or true density based on the inclusion or exclusion of the pores inside the solid or the interparticulate spaces. Then particle size and distribution, permeability or the hydraulic conductivity, and the moisture content. The chemical properties of municipal solid waste are can be quantified by different methods. So first is proximate analysis. Proximate analysis gives the types of different types of materials present in your solid waste, such as the volatiles or the ash or the moisture content and the fixed carbon content. So the procedure for that is, for moisture content, you can dry the sample at 105 degrees Celsius. Then it basically removes the moisture present, and then after this drying, you can ignite the sample at 50 degrees Celsius for 7 minutes in the absence of oxygen. For ash content, you heat this ignited solid to 750 degrees Celsius for half an hour in presence of O2. And for fixed carbon, you subtract all these values. Next is the ultimate analysis, which is also called CHNS analysis. It basically gives the elements present in the sample. Did anybody post a question? I'll just, if you have a question, you can unmute yourself and ask the question. If there is no question, I'll proceed. So, ultimate analysis is CHNS analysis. So, it is based on the principle that all elements exist in oxide form at about 950 degrees Celsius. So, it the procedure is such that first the combustion takes place, then the reduction takes place, then the mixing and separation, and then finally the detection. So, why reduction is taking place is because NO2 is also present, but we need N2. So, to reduce NO2, we use the reduction part. Next is the fusing point of ash. So, ash is the tendency to form solid clinkers at very high temperatures, and this process is thus takes place at very high temperatures. And based on the increase of temperatures, shrinkage, deformation, hemisphere, and float temperatures are also defined. Next is the lignocellulosic composition. So there can be some lignin or cellulose present in your solid waste. And to measure or characterize that, the extractive method, then the hemicellulosic and lignin and cellulosic methods are used. Next is the leaching test. So basically the landfills which are basically huge waste dumps in the solid in the land. So that is I mean, the leaching test is basically, it mimics the landfill conditions. So it can characterize a number of heavy metals as well as number of chemicals present in the landfills. Next, the heating values of solids were discussed. Uh, of the fuel were discussed, or the solids were discussed. So, high heating value as well as the low heating value. So, the difference between the high heating value and the low heating value is the heat of vaporization of water. So, high heating value includes the heat of vaporization of water. Why? Because it is based on the logic that the water can condense back into liquid, water vapor can condense back into liquid. So when water vapor is condensed into liquid, heat of vaporization will be released. So high heating value includes that heat of vaporization. And bomb calorimeter is used to measure the high heating value of the sample, and the formula was is shown here, and the different terms are, so T is the temperature rise, W is the energy equivalent of a calorimeter. So this is basically a calibration of sorts of the calorimeter. These are the correction terms E1, E2, and E3 based on the formation of nitric acid, sulfuric acid, and the combustion of the fuse wire. So, and based on the different and these correction terms are in such are used in such a manner that correction in calories for heat or formation of nitric acid. So you use sodium carbonate to titrate the nitric acid to measure the nitric acid present through titration. So this is the correction term for nitric acid. Then for correction in calories for heat of formation of sulfuric acid, this is the formula given. And for combustion of fuse wire, so the how much the fuse wire is consumed in the combustion of the fuel, then if the different materials are used, then the different correction terms are given here. So in lecture 19, the environmental laws and regulatory frameworks were discussed, and there are many articles present in the constitution that state the that mandate the state and central government to protect our environment as well as the resources present. So different articles such as 48A, 51A, G, 21 and 47 are present in the constitution that safeguard the environment as well as the resources present. Then Environmental Protection Act 1986 and many other protection acts such as Air Pollution and Control Act, Water Pollution and Control Act, they are also present to safeguard the air and water resources. The regulatory framework in our from the Indian perspective is that the center has the Ministry of Environment, Forest and Climate Change, which is basically controlling the which is basically which is basically there to safeguard the environment and the resources, and it basically controls the Central Pollution Control Board, and this Central Pollution Control Board then controls the state as well as the SPCB. Next was discuss the international global organization. There are various global organizations which meet either annually or biannually or in maybe 4 years or 2 years to discuss the policies, the general global policies which can be implemented so that the resources for the whole world can be protected. So we now discuss the sample questions for based on the assignment 4. So first question is identify the analyzer in the schematic diagram given below. Can anybody give me the answer for this?
NTIR.
Yes, correct. Yeah, because in the image itself you can see that there is some IR source present. So all the options are this is chromatography, this is chromatography. Beta attenuation is you does not use IR. So yes, IR is the correct answer here. Second question.
Madam,
Yeah,
madam, I am from commerce background. Can I study that course?
which course? This course?
Yes.
Yes, of course. If you have an interest in this course and you are willing to learn, yes, of course. But I think there is some prerequisite knowledge required for this. So if you have that knowledge, then of course you can study. Are you enrolled in this course?
Yes, madam.
Okay. Okay. So yeah, you can study this course if you are willing to learn. If there
Okay,
is
madam.
any need for this course, then of course you can study. If there's no need, I don't think you.
Madam,
Okay. Yeah.
just
Anything else?
no, madam.
Okay, then I'll proceed. The second question is which analytical instrument is used for the measurement of trace metals in solution? So for trace metals, atomic absorption spectrum. Yeah, but you're saying something? Okay, so atomic absorption spectrophotometer is used. Turbidity meter and pH meter and conductivity meter are used for different characterization, but atomic absorption spectrophotometer is used for trace metals. So atoms when ionized and in the flame, then uh, the radiations which are absorbed by them, and they can be used uh, to these absorbed radiation, then the transmitted radiation which reach the detector. Based on that, we can find out the trace metals present in the solution. So the third question: find out the missing steps in the following depiction of ultimate analysis. Can anybody give me the answer for this? What will be A and B here?
Option B.
Huh?
Option C.
Option C. Why do you think so? Option C.
और इसके अलावा बाकी इसमें फर्दर कोई कमेंट नहीं है मेरा
Because in B it should be reduction because the complex compound should be reduced to the ultimate forms of CHNS.
Mm-hmm. Okay. So you are saying B or
C.
C? No,
C.
it will not be C. It will be B na, because after combustion you need reduction so that if there are any oxides of N present, so you need to reduce it to N2 form. So reduction will be A.
Okay.
And then after mixing there needs to be separation of these, because then they are mixed. So how do you you need to separate them so that separately you can detect these elements. So the separation is required. So the correct answer here is the second option, which is A, reduction, and B, separation. So the wrinkler's method is used for the measurement of. So can anybody give me the answer for
Dissolved
this?
oxygen.
Yes, correct.
Dissolved oxygen.
Yes, dissolved oxygen. The next question is: net calorific value is the gross calorific value less the dash of water in the product of combustion when cooled. So, what will be the answer here? First, can anybody tell me what is net calorific value and what is gross calorific value? It is equivalent to heating values, but can you tell me what is net calorific value and what is gross calorific value? Can anybody give me the answer? Okay, I'll let you know. Net calorific value is basically the lower heating value, and gross calorific value is the higher heating value. So, as we have discussed already, higher heating value is the sum of lower heating value or low calorific value or net calorific value plus the heat of vaporization. So, here the correct answer will be heat of vaporization. So, the difference between the gross calorific value and the heat of vaporization is net calorific value, which is the lower heating value. Next question is 3 grams of a dried agricultural waste is leached with benzene and ethanol. After leaching, the residue is dried in a hot air oven at 105 degrees Celsius to a constant weight of 1.6 grams. Then this dried material is put in a flask containing 150 ml of N by 2 NaOH solution. The mixture is boiled for 3.5 hours with recycled distilled water. After this, the residue is washed with distilled water till all the sodium ions are removed and dried to a constant weight of 1.3 grams. Determine the extractive and hemicellulosic content of this waste on dry basis. So for the extractive method, they are saying that for at 105 degrees Celsius, after mixing with the reagents, the constant weight is 1.6 grams. So for the extractive percent, it is basically M1 minus M0, M1 minus M2 upon M0, I think. So just a minute, M0 minus M1 upon M0. Yeah. So it will be 3 minus 1.6. Okay. So 3 minus 1.6 upon 3 into 100. So this is for extractive. And for next, they are saying that for 3.5 hours, mixture is boiled after mixing with 150 ml of zero point 0.5 normal NaOH solution. So the after the removal of ions, the constant weight after drying is 1.3 grams. So for this, it will be 1.6 minus 1.3 upon 3 into 100. So hemicellulose content is given by this formula. So 3 minus 1.4 by 3 and 0.3 by 3. So this will be 10% and this will be around 46.66%. So the first option is correct here. And the formula used is also given in the explanation. Next is the COD analysis of a wastewater sample is carried out through chemical method using zero point 0.1 normal potassium dichromate solution as reducing agent, and excess dichromate is titrated against ferrous ammonium sulfate. 20 ml of wastewater sample is used. 200 ml of wastewater sample is used. The titer values of ferrous ammonium sulfate are 60 ml and 85 ml for original sample and blank sample respectively. Determine the COD of the sample. Assume there is no interfering element in the sample. So, as we had discussed already, the difference between the excess chromate ions present in the blank and the original sample gives us the COD value. So, based on that formula, the formula is 8,000 into the difference between the chromate ions present in the blank minus the sample into the normality or the concentration of the chromate solution, dichromate solution used. So this is N upon the volume of the sample. So here we are given 8,000, and if you see, all should be in the ml units. So B minus S, so 85 minus 60 will be 25, and N is normality, so 0.1 normal. So 0.1, this N by 10 is 0.1, so that is used here, 0.1, and volume will be all the volume units are ml units, so 200 ml. So this is 25, this is 0.1. Okay, so 40 into 25 into 0.1. So this is 1000 into 0.1. So this is 100. So 100 milligrams per liter comes out. So the correct option here is 100 milligrams per liter. Next question, a solid waste with 1% S is combusted in a bomb calorimeter the temperature of the bucket water increases from 26 to 28 degrees Celsius. The water equivalent of the calorimeter is 2402 calories per degree Celsius. 1 gram sample is used, so the mass of sample is 1 gram for the test, and PAR 45C10 wire is used for ignition. Out of the 10 centimeter wire, 2.6 centimeter is unused. Okay. To titrate the calorimeter washing, 24.2 ml of 0.0709 normal sodium carbonate is required. Calculate the gross heating value of the waste. Consider the thermometers are working perfectly. So the calorimeter gives the gross heating value or the higher heating value. So the formula is such that, as we have already discussed, HHV will be temperature rise, which we denote as T, into the water equivalent, which is W, minus the correction values, which are E1, E2, and E3, and upon the mass of the sample. Sorry. So temperature rise will be 26 to 28, so 2. This will be 2402, and E1 will be based on the ml of so the volume of sodium carbonate used. So this will be 24.2 minus the so here it is written 1% S is combusted in a bomb calorimeter. So the formula given here is just a minute. So the correction term given here is so 13.7 into the percent of S and into the mass of the sample. So so here 1% into the mass, which is 1. So 13.7 into 1 minus uh, it's given 2.6 is unused. So 10 minus 2.6 we need. So the amount of consumed wire is required. So 10 minus 2.6 into I think 2.3 based on the material of the wire. So yes, 2.3 into C3. So and whole upon 1. So this will give us the answer. If you calculate it, it will give us the answer as 4749.09 calories per gram. And this is the calculation given here. Next is, from Indian constitution perspective, identify the articles related to the environmental legislation from the options given below. So as discussed earlier, all of these options are correct. Article 48A, Article 21 and 47, they are given in the constitution to safeguard our environmental resources. So all of the above are correct here. And the Water Prevention and Control of Pollution Act was enacted in India in the year. Can anybody give me the answer for this if you have gone through the material? Huh? I'm sorry, I didn't hear you. Can you repeat it? Again, it's not audible. So the
1974.
yeah, correct. The correct answer is 1974. So any questions?
The second last question,
Mm-hmm.
since we have to put the values of constants from the tables and all,
Yeah.
so do we need to mug up those values?
The values are like there are basically for three correction terms. So it's not that elaborate in the sense I'll just
I mean, for the exam, do we need to mug those up?
for the it's not okay. So the correction term, these are the formula given. So yes, if a mostly yes, you will get a bomb calorimeter question. So these are the values for different types of wires used. So 2.3 into C3, 2.7 into C3. And these values are not, I mean, it's not difficult to remember them or memorize them. So yes, of course, you will have to. In this case, yes. Any other question? Any other question? Anybody else? So if there are no questions, so I'll go ahead and end the session. Thank you everyone for joining. Thank you.